Boys and girls, I'm sorry I cannot be with you today in person, but I'm here with you via computer. What I want us to do today is work on using the Pythagorean Theorem. We're going to use the Pythagorean Theorem to find the missing side of a right triangle. Now, whether you're given the two legs and you have to find the hypotenuse, or one leg and the hypotenuse and you got to find the missing leg, doesn't really matter. You should be able to manipulate that theorem, a squared plus b squared equals c squared, to find that missing side. We're also going to review on how to find the square root of numbers, especially numbers that are not perfect squares, and how to estimate to the nearest tenth. Well, let's take a look at our assignment. I'll do a couple problems with you together. The rest you're going to do on your own, and what you don't finish in class today will be homework. So get through as many of these problems as possible, and I will see you on Thursday. Have a good day. Okay, boys and girls, let's take a look at the first problem. The first problem asks, do the following lengths form a right triangle? Well, let's plug them into the Pythagorean Theorem, and if they work out to make the Pythagorean Theorem true, then we know that this must be a right triangle. Okay, now first of all, I'd have to assume that they're implying that this angle right here must be the right angle, and this is the hypotenuse since it's the longest side. So I'm going to use my formula, a squared plus b squared is equal to c squared, the Pythagorean Theorem. And I'm going to say side A is 6, side B will be 8, and side C, which is our hypotenuse, would be 9. So let's see if this is true. 6 times 6 is 36, 8 times 8 is 64, and 9 times 9 is 81. 36 and 64, well, 4 and 6, that's 10. Carry the 1. 1 and 6 is 7, plus 3 is 100. 100 is not equal to 81. So this is not, okay, it is not a right triangle because the Pythagorean Theorem does not work for it. Let's take a look at number 2 now. We're going to test number 2. Here's a triangle, and we need to test to see if it's a right triangle or not. If it's a right triangle, we should be able to plug this data into the Pythagorean Theorem, and it should be true. So, once again, we know it's a squared plus b squared is equal to c squared, which is the hypotenuse. Side A would be 5 squared, plus side B, which is 12, so we're going to square that. And our hypotenuse is side C, that's 13 squared. And 5 times 5 would be 25. 12 times 12 is 144. And 13 times 13 is 169. We should have all of our square roots, perfect squares, committed to memory up to 15 by now. When we add this up, we get 5 and 4, that's 9. 2 and 4 is 6, bring down the 1. 169 is equal to 169. Yes, this is a right triangle, so this must be our right angle here. Let's move on down to number 7, and this is the traditional way that we would use the Pythagorean Theorem. We have a right triangle here. They're telling us it's the right triangle. It's a right triangle. And they give us two sides, and they happen to be sides A and B, and then we have to figure out the hypotenuse. So we use our formula, a squared plus b squared is equal to c squared. This organizes our thoughts and information, make sure that all of our data lines up perfectly. Side A we'll say it's 4, so we square that, plus side B, we'll call this side B, that's 8 squared, and then side C, that's our mystery, that's what we don't know, and that's what we want to figure out, that's c squared. So 4 times 4 is 16, 8 times 8 is going to be 64, and we'll bring down our c squared. 16 plus 64, I believe that's going to be 80. 80 is equal to c squared. Now what we want to do is we want to find c, not c squared. So we need to do the inverse operation of squaring something, which is finding the square root of it. Okay? And the square root of c squared will just be, it's just going to be c. But the square root of 80, now that's the trick here, and this is where we need a little review. Okay, if we want to find the square root of 80, which is 80 is not a perfect square, I got to figure out what perfect square is in between. I know that it is somewhere in between 81, okay? Okay, 81 is a perfect square, which is 9. Okay, and I know that it's somewhere, it's got to be less than, or I should say greater than, the square root of 64, which is 8. So it's somewhere between 8 and 9. Okay, well, how do I figure that out? Well, the first thing, I know it's going to be 8 point something. Okay, well, what I'm going to do is I'm going to look for the difference between these two numbers, 64 and 80. The span between those two will be, well, I'll go up 6, that'll get me 7, 16, that'll get me up to 80, it'll have to be 17. Okay, so the span between these two is 17. And then I need to see how far along the way it is. And the difference between 64 and 80, that would be 16. Okay, add 16 on that, that gets me up to 80. So I'm 16 17ths of the way to 9. Not quite there, so it's going to be, so what I need to do is I need to divide these two numbers. So I'm 16 17ths of the way, which means I need to take 16 and divide it by 17. And I bet you anything, 17 will go into 160 at least 9 times. 9 times 7 is 63. Carry the 6. 9 times 1 is 9, plus 6 is 15. I subtract, and I'm going to get a remainder that's less than 17. It's a remainder of 7. I can stop there. So what I know is it's going to be 8 plus 9/10. Okay, so and also too, let me change that. It's not necessarily equal. It's going to be approximately. I'm estimating here. I'm estimating. So it's going to be approximately 8.9, and that's a pretty close approximation. Okay, boys and girls, let's take a look at number 13. Here again, they give us the two legs, and we have to figure out the hypotenuse. So, okay, let's set up our equation. A squared plus b squared is equal to c squared. A is 5, b is 2, and c is our unknown. 5 times 5 is 25. 2 times 2 is 4. That's equal to c squared. 25 is 29 is equal to c squared. And again, so I know that I need to find the square root of these two. I need to do the inverse operation. And I'm going to get an approximation. C is going to be approximately what? What's the square root of 29? Well, I know the square root of 29 has to be somewhere, it's less than the perfect square of 36, which is 6. And it's greater than, it's got to be greater than the square root of 25, which is 5. So it's 5 point something. It's 5 point something. Again, we need to find how far along the way it is from 5 to 6. So when the span between 25 and 36, that's going to be 11. Okay? And then how far along, how many 11ths of the way is it there? It's only 4 11ths, because if I add 4 to 25, that'll get me to 29. So it's 4 11ths of the way there. And if I turn this into a division problem, 4 divided by 11, that's going to give me the decimal amount that I can add to 5. So 11 will go into 43 times. That's 33. And I get a remainder of 7. Bring a 0 down. 11 goes into 70. 6 times, which is 66, and I can stop there. If I want to round to the nearest tenth, and that's what we're asked to do, 36 hundredths will round to 4/10. Okay, so I take 5, add my 4/10 to it, and I get 5.4, or 5 4/10. So my side C is approximately 5 4/10. Let's take a look at number 16. Now, number 16 is different. They give us the hypotenuse this time. We have to figure out one of the legs. We're still going to use our Pythagorean theorem, which is a square plus b square is equal to c square. Okay, side A I'm going to call 3.9. I'm going to say it's 3.9. I need to square that. Plus b square, which I don't know what side B is. That's the mystery side. And then my side C is the hypotenuse, is 11 squared. So let's do some squaring here. If I take 3.9 and square it, which is 3.9 times 3.9, I'm going to get 15.21 plus b squared, and then I know 11 times 11 is 121. Now what do? I need to get the variable on one side so I can isolate. Treat it like this formula is just an equation. So I subtract 15.21 from both sides. Bye-bye to that. I bring down my b squared is equal to it's going to be 105.79. Okay, now I need to find the square root of both of these. Got to do the inverse operation. I'm going to get b is approximately, well, I know that the square root of 105.79, okay, it's going to be less than the square root of the perfect square 121, which is 11, and it's going to be greater, though, it's got to be greater than the square root of 100, which is 10. So it's somewhere between 10 and 11. It's going to be 10 point something. Again, let's find our span here from our two perfect squares. The difference between 100 and 121 is going to be 21. And our difference between, this is going to be lovely, between 100 and 105.79 is going to be 5.79. So I got to take 5.79 and divide it by 21. Okay, 21 will not go into 5, but it will go into 57. I think 2 times, which would be 42. I do some subtracting. 7 minus 2 is 5. 5 minus 4 is 1. I bring down my 9. 21 is going to go into 159, I think 7 times. 8 times would be too many, so it's going to be 7. 7 times 1 is 7. 7 times 2 is 14. I subtract and I get the difference of 12. And I can stop right there. 27 hundredths is going to round up to 3/10. So I take my 10, I add 3/10 to it, and I'm going to get 10.3 or 10 and 3/10. So my answer is 10 and 3/10. That is approximately the right length of side B. Always, boys and girls, I hope that that was helpful. We did a couple problems together. The rest you need to do on your own. Please, please, please show all your steps. Don't try to do this stuff in your head. And what's not finished in class will become homework. So work hard and get as many of these problems done as possible today in class. And I will see you tomorrow. I miss you guys already. Bye-bye.